Everyone, welcome to Space Debris Day. My name is Michael. I'm here at the H.R. MacMillan Space Center here in Vancouver, British Columbia, located on the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. The big news of the day, of course, is a bunch of missions going to Mars. And as always, I'm joined by our astronomer, Rachel. Now, Rachel, we're not going to be talking about Mars today. We're going to save that for tomorrow. So if anyone is out there watching and want to talk about the UAE and China both arriving at Mars, we're going to deal with that tomorrow at 2 o'clock in our normal Ask an Astronomer session, right, Rachel?
Yeah, I'm very excited for it.
So Rachel, we are going to be talking about Space Debris Day. This is something we've done for the past couple of years, and you're going to go over a little bit of a presentation about what space debris is from an astronomer's perspective, right?
Exactly. So I'm very excited to talk about this because it's such an important issue for observations.
And it's a very complex issue. We're going to take a couple different perspectives as well. We've been joined by a couple experts on space debris. So we've got Dr. Brian Weeden, who is the Director of Program Planning for Secure World Foundation. It has nearly for 2 decades professional experience in space operations and policy. Hi, Brian. How's it going?
Going great. Happy to be here.
Tell us a little bit about Secure World Foundation. It sounds like something that maybe Starfleet Academy might be using to help us out here, but that's not exactly what we're talking about here, is it?
No, not quite. We're a US-based nonprofit organization, and our focus is working to ensure the long-term sustainable use of space for benefits on Earth. So our work is all about how we can use space in a sustainable manner, dealing with challenges like space debris and congestion of the things, and then how space provides benefits back here on Earth.
Okay, and you're going to give us a little bit of a presentation, sort of an introduction into sort of like space policy, if that's a word that if you're here in joining us here in the Zoom webinar, if that's new to you, you'll explain it, but then we'll also can get into some of the meat of it as well. So if you have any questions, I think Brian is the one to go to. Is that right? Awesome. And also joining Brian is someone who we have seen here in person for our last couple of space debris events. We've done this is our 3rd year in a row. This is the first time we're doing it online, and it's someone who helped us found Space Debris Day, and that is Dr. Rosengren, who's now a Ph.D. assistant professor of mechanical and aerospace engineering at the University of California, San Diego. Hey, Aaron, how's it going?
Going. Happy to be here.
I'm imagining the weather's a little bit better down in San Diego than it is here in Vancouver and Washington, D.C. Where Brian, Rachel, and I are.
I think I remember our first Space Debris Day we had snowed out, right? So
it's sort of a tradition.
Yeah.
So tell us a little bit about, because yes, February 10th is what we've coined as Space Debris Day. So why is February 10th something that we call it this?
Right. So it's sort of akin to Asteroid Day when, the Tunguska event was sort of the, commensurate day that we sort of raised awareness for the threat imposed by asteroids to our, our modern world. And really this whole space sustainability has been, really brought back into the light based on this event that happened in 2009 with Iridium and Cosmos. These are two intact satellites. One was active, one was a debris. And they collided, and this sort of raised the awareness that this is a real problem, that despite space being big, as we say, that collisions can actually occur. So the first Space Debris Day occurred in 2019 on February 10th, the 10-year anniversary. And so this is our 3rd one, and we're hoping to keep this going for years to come.
Yeah, absolutely. So you're going to sort of wrap us up with sort of building upon Brian's policy and kind of like where we go next. And that's, of course, like every year we kind of get to that question of where we're going to go. And of course, everyone that's joined us here in the webinar, we'd like to hear from you as well, because part of what we're doing here with space debris is to raise awareness and also, hear from people, whatever industry you're in. Maybe you're not in the industry at all. This is all brand new. We'd love to hear from you and your questions. So just use the Q&A feature here in webinar, and we'll get to everything over the course of the next 45, 60 minutes or so. So let's get started, Rachel. Let's take the cosmic perspective from an astronomer's point of view, and let's have a look up into our night sky and have a look what we're dealing with here when we talk about space debris.
Sure. So I thought I'd start in the backyard of the Space Center. And when you hear the word pollution, chances are your brain goes straight to thinking about air, water, or land pollution. But the less common form, which I'll talk about today, is light pollution. And especially for us at the Space Center, a big source of that light pollution comes from downtown. But what if we remove that light? Well, we'll be able to see a lot more of the sky, like the breathtaking view of the Milky Way galaxy if you travel to a dark sky location. Now, has anyone in the chat seen the Milky Way? If you have, let us know. But it's okay if you haven't, because we've done surveys of the artificial night sky brightness, or what we call sky glow. And that gave us an estimate that the Milky Way is no longer visible for more than a third of humanity. And it's all thanks to light pollution. Now, they live under skies that are so washed out by man-made light that the Milky Way is virtually invisible. But it's not just light pollution from urbanization that we have to worry about. It's both ground and space-based observatories are wary of light pollution from satellite constellations that'll affect astronomical observations. Now, how well a telescope can observe small, weak, and faraway objects increases with the size of the mirror because you can collect more light. And a telescope's sensitivity also increases with diameter, or more precisely, the square of the diameter. And last year, a study done by the European Southern Observatory, or ESO, estimated that up to around half of the exposures around twilight obtained by large telescopes will be severely affected by satellite constellations. And this is especially important when we're talking about wide field surveys, like this one, which is the Vera C. Rubin Observatory, which is previously called LSST. Now, these types of telescopes can scan large parts of the sky very quickly, and that allows us to spot potentially hazardous asteroids and short-lived phenomena like supernovae. Alrighty, so I'll back up a little bit here. So we have these red dots around here. And this is an estimate of the number of discoveries that, or discoveries of supernovae that the Rubin Observatory will find over a period of a quarter of a year in 2023. So it's quite a bit. But if we take a look at what it looks like on the ground, this image shows the night sky above the ESO's Paranal Observatory, and it's about 90 minutes before sunrise. Now, about 100 satellites could be bright enough to be visible with the naked eye, and the vast majority of these are actually marked by these green circles that you see here, with most of them being low in the sky and rather faint. But the red satellites in the middle are the ones that will be in the part of the night sky where most observations are taking place, and they'll be relatively bright. And so towards the middle of the night, more satellites will actually fall into the shadow of the Earth, which is on the left-hand side here, and that can help us mitigate a few of these effects because we can observe satellites that are in the Earth's shadow and they'll be invisible, so we won't be able to see them. But another way of mitigating this effect is to compute satellite positions and avoid observing when one will pass overhead. And we do this for the ISS, but Starlink satellites can change their orbits autonomously, so observations can't really be scheduled to avoid them. Now, both of these countermeasures severely restrict how much and for how long we can look at our sky. So I said that 100 of these satellites will be visible to the naked eye. What does that look like? Well, we can take a look. And it'll look a little bit something like this. But satellite constellations aren't anything new. We have navigational constellations like GPS satellites and weather networks that we use for things like disaster monitoring or search and rescue. But even though these are also satellite constellations, they typically number in the dozens and not the tens of thousands or thousands that are going up there now. And well, you might think that, well, Earth is huge and these satellites are relatively small. So what's a few thousand more satellites between friends? Well, let's take a look at the numbers. So here are the 4 major satellite constellations from various companies, the number of satellites they're planning to launch, and how many have already been launched. Now, Starlink is quite obviously the largest, outnumbering the others by thousands. And there are other smaller satellite constellations as well, but I didn't include them because their numbers are below 1,000. Now, here are the same constellations with the name of the manufacturer and the altitude at which they will be orbiting at. Now, keep in mind that the ISS orbits in low Earth orbit around 400 kilometers up in space, and SpaceX is hoping to launch another batch of satellites into orbit around 330 kilometers up in 2024. And we can take a look at what that Starlink constellation looks like here at the Earth. And if I back up a little bit and turn on the Starlink satellites, oh, they're here. So these are all the Starlink satellites. And if we throw in the space debris that's also floating around there, that is what it looks like. So it's very, very dense collection of stuff that's in our airspace. But the intention behind the satellite constellation is a good one. And it's intended to act as a global communication system and provide internet to underserved areas of the planet with high speeds and low latency. And here's an example of it in action with a tweet from Elon Musk. But it's with good reason that astronomers have considered light pollution from satellite constellations to be the #1 most pressing concern in ground-based optical astronomy. And that's not only because the Rubin images will contain at least one satellite trail in 30% of all images, but these trails also produce artifacts in the data. And now these artifacts can be mitigated through algorithms like we see here on the right, but they can only do so much. And it's not just optical observers that are severely impacted, radio astronomy is affected as well. Now, recent advancements in radio astronomy include producing the first image of the black hole with the Event Horizon Telescope, which is a global network of radio telescopes, and also learning more about the formation of planetary systems. And these were only possible with regulations safeguarding the radio sky from interference. And even though there have been significant efforts to try and reduce that interference, we can still have overlap from out-of-band signals that cause that unwanted interference. So in summary, even though astronomers around the world recognize the benefits of having a global broadband internet, we are concerned for the future of astronomical observations and progress in space science.
So Rachel, that was a very nice way of saying astronomers are want people to get to fast internet, but they're also like you're blurring out our telescopes and you're not making it easy for us.
I wanted the presentation to have the feel of a strongly worded letter.
Well, Brian, let me throw to you so that perhaps you could maybe ask a question around about to Rachel. You know, how much of these missions, the astronomer's perspective, how much does that go into policy thinking? Are astronomers and the telescopes we're building, are they being thought of when these conversations are happening around policy?
Well, they are now, but no, historically they have not. In the United States, where Starlink is currently being licensed, and in most other places, there traditionally light pollution was not part of the consideration when you were looking to do regulation or licensing of these constellations. But there certainly are talks now about whether or not it should. And I'm not sure. I mean, so there's a whole other discussion whether or not that's going to address things. But yeah, that's really a consideration going forward. And I'll say, you know, Rachel, I've heard that over the last several months since this was first identified, there's been a lot of engagement between SpaceX and the astronomer community about this. Is that been happening? And has there been some actual progress there?
Yes, there's a lot of back and forth. SpaceX has said that they'll have concessions, but astronomers are finding that he's not really following quite all the way through, so just enough to keep us at bay. But we're hoping that perhaps in the future he will start to recognize that this severely affects observations, and we want progress in space science and space exploration, so that's quite important.
Yeah.
I remember one of the things that Elon Musk said, I think, before Starlink went up, was that he had no idea that this was going to be an issue when they proposed these missions, as if sort of like he was completely oblivious. Is that a valid thing? Would he have been completely oblivious, or was there somewhere along the line where there are people sort of like in the middle that probably should have raised their voices?
So no, it's not a valid excuse because it factors into engineering. So when Elon Musk was first confronted about throwing all these satellites into space, he said, well, we'll just paint them black and that'll fix it. You won't be able to see them anymore. But the problem with that is black absorbs a lot more heat. And so in the infrared spectrum for astronomy, we're affected even more with black satellites. So in his engineering those space components to be able to withstand the heat from the sun, he had to have considered that. So I'm going to call him out on that one.
Let's bring you in, Aaron. As we're going to get to sort of like the future, and what do you think? I'm going to bring you sort of like the voice of positivity as we look to the future. What are some things do you think that that you think will be hopeful for helping this issue?
Right. Well, I've never really been the voice of positivity on this, but I would have to say that just as Rachel brought up the point about painting it black as being a simplified sort of solution to the problem. The other issue is sort of we don't really understand at a fundamental level the carrying capacity of orbits. So these satellite constellations that they're putting up there, they want to have them in very narrow shells, and we all sort of know what happens when you do that. I mean, Iridium Cosmos sort of showed us the way to the future. So that's not terribly positive. Now, on the other hand, though, if everybody sort of works more holistically together, there are ways that we can actually do this. And I'm looking forward to having satellite internet so that I don't have to rely on Cox here in my house now. So, I really think that there are a lot of ways, and if the interaction is stronger between, the researchers and the policymakers and really people who are sort of advocating for this, their solutions are out there. It's just, we have to get those to the people who are making these, big changes. So.
Absolutely. And of course, if anyone out there watching, if you have any questions for Rachel, before we move on, Brian, anything else you want to add about observational sky pollution?
No, I'll just say, I think in somewhat to Elon's defense, I don't think anyone in our community, the sort of the traditional space operations, even the policy community, was really aware or thinking about the light pollution. Like I said, it just wasn't something we were thinking about it. And now, of course, in retrospect, it's like, well, of course we should have been thinking about that.
It does sort of like bring to mind sort of the kind of thinking that space and a lot of things that we do in space brings up that forward thinking and kind of like really thinking about the future. Even as we are going to Mars right now today, this week, in this past couple of weeks, we're doing all these things about Mars, but now is the exact time to be thinking about space policy around Mars, even like sort of like the ethics of Mars, even if that seems so far in the future. I think the space debris is one of those things where like this could potentially have been foreshadowed decades ago, probably.
And I will point out that there actually are people working on this issue for the moon, because there's now a fair number of satellites orbiting around the moon, and keeping them from colliding is actually somebody's job right now.
So we're gonna get to you, Brian. So we're gonna get into the meat of space policy. We got our first question that came in from Ellis. Maybe this is a question for Aaron, maybe about is there an incentive to collect space junk in terms of recycling metals or parts like that?
Right. This is a whole area called on-orbit servicing, and in fact, I think there was a DARPA project, and I don't know if it's still ongoing, but to research this sort of how do you grip grapple with these satellites that are maybe not, they're tumbling in ways that we don't have quantifications of, and how do you sort of fix those satellites on orbit? It's a very difficult engineering problem. It's got some policy implications as well. I mean, you can't really go up there and take somebody else's trashed satellite. It's there's actually some sort of rules to the road in that regard. But this is something people are thinking about, and there's an entire company called Astroscale. It's a private company, and they're thinking about ways and trying to do things to really do this, to recycle material, to sort of service satellites that have a failed piece, to sort of not create that space debris problem, and also to sort of to deorbit these guys after their end of life if they can. So this is being thought of. Certainly there are incentives, but it's very expensive to get into space. So
that actually brings up. Sorry, go ahead, Brian.
I would say, just to add into that, so it's certainly a possibility. The other challenge is the material science of this. So these objects have been in orbit for years, sometimes decades, exposed to radiation, exposed to intense hot and cold cycles. Sometimes they still have like toxic rocket fuel remaining inside of them. So there's a lot of uncertainty as to whether or not that material is degraded over time. A lot of the stuff is like aerospace grade titanium and aluminum. Recycling that will be difficult even here on Earth with very advanced factories and chemical processes. Trying to in orbit is going to be pretty challenging. So Right now, the focus is just removing it from orbit. But there are certainly, as Aaron pointed out, there are indeed companies that are trying to figure out, can we turn these into fodder for orbital 3D printers? Can we reuse this in some fashion?
Right.
This actually brings up an. So I was going to mention an episode of Star Trek Lower Decks. I don't know if anyone's been watching the new animated series, but there's an actual scene that describes exactly what you're talking about, Aaron, where there was a decommissioned Starfleet piece of space junk that was floating out there that some space pirates had kind of claimed that they were going to take. And of course, the Starfleet didn't want to allow that, but they also didn't want to create an incident to start a fight with these small group. It was very interesting. They were sort of like egging on the larger Starfleet, like, we're going to take your thing, you know, if you're going to take it from us, you're going to have to take it with force, which would be an act of war, essentially, which does sort of like lead us into, you know, maybe some policy stuff that we're going to get into, Brian. But we got one more question to get to from Callum from Toulouse. Welcome, Callum. Could you please tell me about the impact of mega-constellations on space-based astronomy? I'll maybe throw that one to you, Rachel.
Sure. So the main one is getting things up into space and also where they're going to remain in orbit. So we have Hubble, which is going around in low Earth orbit as well. And to avoid that, we're doing things like putting these telescopes a little bit further away. So JWST, which hopefully launches this year, will be put in a stable point that is away from the Earth. So that helps us a little bit, but it is very costly, it's very expensive, and also it's hard to do. So and all in all, not a big fan of the mega constellations.
Well, so somebody must, and I'm sure it will be helpful. But let's switch the conversation to a policy one, to bring in sort of what's being thought of as these mega constellation and future missions are being thought of. And Brian, let's get an introduction into space policy.
Sure, happy to do so. Let me pull up my, I've got a few slides here. So I'm going to start with just sort of a brief overview of what we talk about policy here. So first off, what is policy? Because this word is thrown on a lot, even in the space community, and a lot of people don't know what it is. I've got a few different definitions up here. The one I particularly like is the last one there. How, why, and to what effect governments pursue particular courses of action or inaction. So when we talk about public policy, we're talking about there's a problem in the world, whether it's, you know, climate change, or it's pollution, or it's potholes in the road, or whatever. And the public policy is a government's approach to how to address that solution. Or maybe they decided they're not going to address that solution. So that's what we're talking about when we say policy. When it comes to space, and I want to talk, I'll frame it in space sustainability, which is how can we use space in a sustainable manner. There's several different pieces of this we talk about. In terms of on-orbit activities, we talk about debris mitigation, which is steps to reduce the creation of new debris. Think, you know, stop littering. There's space traffic management, which is steps we do to minimize the impact of debris on space operations, other activities. So think, you know, traffic lights and, you know, police out there signaling stuff. And then there's active debris removal, which is actively removing the existing debris that's already up in space. There's tens of thousands of things bigger than a baseball. All of that are supported by something called space situational awareness, which is using telescopes and radars to track things in orbit, estimate where they're going, measure their size, sort of know what's up there, and then national regulations and oversight. And that's the piece I'm going to focus on here in my talk, because that is sort of the government's policy and then how they implement that through regulations for all these kinds of space activities. I'm going to talk about the United States for a second, just because they sort of have the most well-defined policy in this area, but there's lots of other countries that are working on this, including Canada. So the United States government started talking about debris policy in 1988. And from there, almost every presidential administration since there has taken what was before and sort of added a little bit to it. So at the very first, it started with, we're going to minimize creation of debris. Then it said we're going to encourage others to adopt those same minimizations. Then we're going to have guidelines for the minimization. And then we're going to have national standards. I'm going to put those into licensing. Then we're going to actually talk about preserving the environment, preventing collisions, look at removal. And then finally, in the last administration, we're talking about developing, maintaining flight safety standards and sort of ways to coordinate traffic. Not all these have been entirely implemented, I would say. In particularly, in 2010, there was a policy statement to look into debris removal technology. That really hasn't materialized. And I can talk more in the questions and answer section about why. Today, the conversation has moved from just debris mitigation to something called space traffic management. That's a big, wide definition, but there's three different parts of that. One is sort of how rockets and spacecraft move through the aircraft system and how they integrate into that. The second is the on-orbit congestion, so preventing collisions. How do we manage congestion on orbit? And then the third is just general licensing and supervising of all the stuff that's going to be going on in space in the future. In the United States, they started working on this space traffic management in 2010. There was an official policy published by the last administration in 2018 that essentially said we think the Department of Commerce should take this on. The challenge is that Congress, US Congress, has not yet done anything on this. So we have some policy statements, but we don't really have much funding or any kind of decisions on changing authorities. We are seeing a lot of industry-led efforts where companies are getting together and companies are developing their own best practices. There's a couple different examples up here related to what Aaron talking earlier with satellite servicing. I'm the executive director of this thing called Confers, which is a group of more than 40 companies, all of whom are working on things like debris removal, satellite refueling, satellite repairs, and they're trying to come up with best principles and practices and standards for how to do all those things. Internationally, you've got countries like New Zealand. They've got a contract with a private company called Leo Labs to track satellites for them and then provide that data to the company do licensing in New Zealand. Europe's got a whole bunch of different things going on. They've got tracking efforts. They've got different national efforts. Japan is working on a lot of these issues. And many other countries, including Canada, are looking at how do we improve our ability to track stuff in space and how do we kind of beef up our licensing oversight of activities. Within the United Nations, something called the UN Committee on the Peace Uses of Outer Space. They just finished an 8-year discussion on guidelines for long-term sustainability. They touch on things like debris mitigation, avoiding collisions, SSA sharing, national policy. They're now talking about how that's all going to be implemented. And there's some initial discussions on what space traffic management might look like. I think the point I'll make as I close is back to sort of what Rachel was talking about. Nowhere in this that I mentioned light pollution, because traditionally that is not something that the licensing agencies or the governments thought of when it came to licensing satellite constellations. So this is a really new thing. And right now, the U.S., which licenses Starlink and Kuiper and not OneWeb, but all the other things, there really isn't a mechanism for the government to consider light pollution in its regulation and licensing of these companies, at least not at this moment.
Michael, you're muted.
Thank you, Rachel. Aaron, where do you sort of see things like light pollution becoming a little bit more present when it comes to space policy? Like you say, there's not a mechanism. Brian just said there's not a mechanism right now, but are there ways? Like, where does it have to start? Does it have to start with the academics? Does it have to start with the NASA teams or any of the governments that are have funded these multi-million-dollar telescope projects that are now having their data being obscured? Like, where do you think it needs to start to address some policy issues there?
Certainly it was the scientists who sort of voiced their opinions very strongly, and I think that did have an effect. I mean, it's, you know, as Brian said earlier, there was communication between the astronomers and you know, these mega constellation designers who are going to change the whole landscape and in the future, right? So there has been that discussion, and it has started with scientists, but we don't really have any power. Right? I mean, unless there's policy, people are going, it's a tragedy of the common situation. People are going to act in their own best interests, which, you know, in the end might, space debris from that point of view, people don't want to pollute their own orbital lanes. So they have a sort of a vested interest in protecting that and designing their constellations in a way that will sort of mitigate their collisions. But in terms of light pollution, there's no sort of incentive I think of for why they would want to do that. I mean, it has to be done at a policy level because, you know, we have this, huge ground-based telescopes that can't really be put in space as you know, Elon Musk would have tweeted earlier, and very, huge investments. So we need to really have this done at sort of it has to be done at a national level and a global level as well. So.
Brian, I'll throw it back to you. With your work at the foundation and perhaps some of the other work that you do, you sort of saw in the Obama administration some of the policies that he put in that hadn't really had much of effect, and we're still sort of unsure what the latest policies were. Do you have any sort of like update on sort of like where you think or things are going to go? Like it sort of seems like what you had just said, that things have kind of stalled. Is that, would you describe it as that? Is like we're sort of like in this holding pattern because we have Elon Musk, SpaceX, and the government agencies all trying to figure out what to do?
So the short answer is it's a holding pattern. The long answer is it's pretty darn complicated. So I would say on the executive branch policy side, we have seen a consistent progress on these issues through the last several administrations, including the Trump administration. As I said, they actually published a space traffic management policy. Now, it didn't explicitly talk about light pollution, but it did talk about sort of expanding sort of the licensing authorities. The challenge that we've had is that expansion of authority can only be done by Congress. And so the sticking point has been getting the US Congress motivated enough to pass some legislation that will change some of these authorities. And so far that just hasn't happened. It's not politically as salient an issue as lots of other stuff the US has been dealing with the last couple of years. And so they just haven't done it. Absent that, all we have are the existing authorities, which is the Federal Communications Commission that licenses these constellations for their radio frequency use. That is the only entity right now that has oversight in the US of any of these of Starlink and other activities. They're not equipped to really deal with light pollution, and that's not part of their mandate at the moment. Their mandate is radio frequency interference and then a little bit of debris mitigation. So that's sort of where things stand. Unless Congress would act, in the very near future to give the FCC some authority to think about things like light pollution, then it's really up to sort of the pressure from the astronomy community to get the companies to kind of change what they're doing.
So it sort of sounds like what they need is probably like a little bit more of a motivation, which sort of like leads us to the next part of our conversation. We can sort of shift away from light pollution and maybe get to something that could actually have some disastrous effects, and that is, space debris, orbital debris colliding with each other. And we got a question from Jeremy, who asks, when will orbital debris become a big enough problem for the world's governments to consider debris removal operations? It seems that active collision avoidance on an individual satellite basis is the current preferred option rather than the large-scale systematic avoidance. Aaron, you want to tackle that one?
Yeah, thanks, Jeremy, for your question. Jeremy was actually one of my students, one of my first students in undergrad. I took my orbital class in undergrad, so I'm happy to see him continuing to care about this field. So he works at Ball Aerospace. So thanks, Jeremy. Welcome. Yeah, it's a great question. I think most people believe that we can just sort of dodge satellites, right? And we sort of saw the sort of ominous picture of the future when SpaceX Starlink was on a collision course with one of these billion-dollar ESA Earth observation satellites, and there was no rules of the road. So who maneuvers? I go left, you go right, whatever that really means in space, right? So this was sort of something that hit really squarely on, that this collision avoidance is not something that can just really solve the problem more holistically. And we need to start thinking about these, really how to get big stuff out of space that doesn't have maneuvering capabilities, right? Out of all the 26,000 or so satellites that we have in our catalog, this is a public catalog, something about larger than your cell phone, let's say. These objects, only about less than 10% have any capability to maneuver. So that's some sort of short-sighted perspective that we can think that we can only do collision avoidance with debris, because a lot of things can't move naturally. Will move off their nominal paths, let's say. But I think we're probably going to start thinking about this a little bit more. We're going to get into that as soon as we sort of see another collision in space. We've only had one so far in our 60 plus years of space activity. So that got people, sort of worried about this, but I don't think enough. So I think once we get another real big Iridium Cosmos event, we're gonna really see some changes, I think, after that. So let's hope we don't do that, but we don't see that end. But I think that's definitely going to be the motivation.
Yeah, I guess that's what it comes down to with a lot of issues, the big issues of the world, whether it's climate change or anything else. It's like we need something bad to happen to really motivate people, which leads us to another question sort of related, is how to get people to care about it. Two sorts of events will get people in general to care, but would it be unfortunate if it had to be an emergency or disaster that did it? So example, if our astronauts got hurt, God forbid, or if critical societal services and functions go out after our artificial satellites are knocked out by debris. Is that certainly the level that we're talking about here, Aaron?
That's
motivation?
That's sort of been the only motivating factor, I think. If you sort of look at it, I mean, there's people going back to Don Kessler who have been preaching about space debris being an issue for decades now. We've only really started to take it a little bit more seriously this time. So it definitely is going to take a cataclysm sort of like event to sort of get us a little bit more tangible to see the tangible effects of this. And if we lose, let's say, our infrastructure and GPS, for instance, we're going to see that across the board. I mean, every single thing that you do from buying your transactions to withdrawing money from your ATM machine, all that relies on this precise atomic clock in space. So if we see some of those infrastructures go out, certainly we're gonna have some changes at that level.
Yeah, great. And thanks, Robert. I didn't realize that it wasn't a question that you're answering from anonymous, and I can't see the chat, by the way. Do people see a chat out there? I don't see it. I thought I turned off the chat. So, but no worries. Let's move on to another question from Cade. How often is the ISS in danger of a serious collision? Since we don't see it happening often, or at least to the public knowledge, does that mean the likelihood of a collision itself is low, or are they just not brought to the public knowledge? Brian or Aaron or Rachel, do any of you know of issues with the ISS?
I can talk a little bit about this one. So the ISS does do orbital maneuvers to avoid big things. And they did, I think, I'm going to say 30 orbital maneuvers last year. But they also have in their shielding, or what's called a Whipple shield, they have a special kind of a shield that will break apart things like meteorites coming towards it. So not completely stopping them, but getting their velocity to slow down and spreading out and dispersing that energy.
Yeah, it's actually, and to build on that, the International Space Station is armored up to a certain size. So for things up to several centimeters in size, at least the end of it that sort of flies into the wind, so to speak, can take those impacts, does not take those impacts. So that's why they generally are concerned about detecting and avoiding the larger things. So 10 centimeters and bigger, that they have to avoid those. And so they'll get predictions several days ahead of time. If they can incorporate a maneuver into like they normally have to do maneuvers to keep the station up because the atmosphere is pulling it down. So they incorporate those in, they'll do it. But there have been a couple of times in the last few years where the warning came too late to do a maneuver. And so the astronauts had to evacuate into one of the Soyuz lifeboats, and they basically just sat there waiting to see if something's going to hit the station and then go back inside. Which the astronauts that have talked about that have said, it's sort of disconcerting to be like, we're just going to sit here waiting for if anything's going to happen.
It's a real life situation like in gravity.
Yeah, I mean that's sort of the obviously it's a Hollywoodized dramatization of that, but you know that sort of fragmentation is what they were worried about, something on that scale.
Mm-hmm.
So we're going to end off with you, Aaron, but we're going to get to one last question sort of around mega constellations when it comes to planetary defense, and that's from Divya. Are there projected issues, you know, for the mega constellations tracking potential impactors when it comes to these things?
Yeah, I guess I can take this one. So, you know, we used to think from the astronomy, you know, astronomical viewing point of view that the asteroids were the vermin of the sky, right? They would get in the way of observing real important astronomical things like supernova or whatnot. And it's become clear that the new vermin is sort of space debris, and now it's going to be these mega constellations sort of crippling our view of you know, things that are of importance for astronomy. And I don't know if people have thought too deeply about, you know, what is going to be that, you know, what is going to be the sort of the, you know, the net result of having all these mega constellations or debris that results from this in the sky to prevent us from doing these things like planetary protection. That's a huge question, and I don't really have the exact answer for that. I think that's something that's on people's radar, especially at, you know, JPL or the Catalina Site Survey in Arizona, where they're actually actively tracking these things. And I know that they often see debris when they're trying to look for these hazards. So it's something that, you know, that problem is looked at from a situational awareness point of view. And actually, space situational awareness is also not just the debris from artificial satellites, but it's also looking at the solar system debris, which is asteroids and comets, these kind of things.
Yeah. So Aaron, you're going to take us to our final perspective. But Brian, I had one question just leading off of what Aaron was just saying about planetary defense of where do you sort of see planetary defense in the level of policy in the government? Are you seeing any progress being made in the policy side of planetary defense? I know that there's a new branch of the military called Space Force, which not everyone really knows what's going on there, but I can sort of envision them perhaps taking a little bit more of a no. Okay, you're saying no.
No. But although that is a common misperception. So the good news is actually quite a bit of focus on this. The United Nations has had a discussion on that has led to there's two international bodies that led out of the UN talks. One is called the International Asteroid Warning Network, IWAN, which is a bunch of different space agencies all getting together to help share tracking data and warning about it. There's something else called Same Page. It's the Space Mission Planning Group, which is a bunch of space agencies getting together to talk about how they might do a deflection mission to kind of make sure an asteroid doesn't hit the Earth. At the national level, I can say that the U.S. there is actually someone at NASA whose job is planetary defense. There's a planetary defense strategy the U.S. has been working on for the last several years across the last couple of administrations. It's got fairly good support. It talks mainly about not only tracking and warning, but also about sort of the disaster response planning, which if there was an impact, that's sort of the thing we'd have to focus on.
Right. So Aaron,
you mentioned Space Force. So yeah, Space Force is nothing into this stuff. Space Force is flying GPS and you know, communication satellites, and that's pretty much it. They're not doing any of this stuff.
I just sort of anticipated that. I was hoping perhaps they might be able to take it on, like, hey, Space Force, you want to take this on? You know, like.
No, for right now, it's mainly the civil agencies.
Right. The space traffic management went not to Space Force; it went to
Right. So Aaron, you're going to sort of like wrap this all up, and we did actually get a question, I think, sort of like will help us transition into how we can go into the future. And that's kind of like this issue of too many people saying debris apocalypse is nigh, nothing appears to happen. How can we harness the environmental pollution issue of space debris to elevate it akin to climate change and get it onto COP26? I'm not too sure what that is. Maybe you know what that is, Aaron?
Yeah.
I'm assuming it's probably like a conference or some sort of event of awareness of climate change.
Right. Yeah. So I agree. I mean, this is sort of a thing that we've heard about for a long time, is that the things, where are the collisions if we keep preaching about this? We've only had one in 60 years. So and certainly the problem is a little bit multifaceted and sort of hard to answer that question with just one sort of that view. And I sort of resonate with that too. That we really we start thinking about this a little bit beforehand. We have a forward-thinking outlook, then it's going to prevent that debris apocalypse. And maybe we won't see the debris apocalypse for a number of years. And if we have one triggered event, it's not going to be like the movie Gravity, the hyperbole that you get this, cataclysm that happens over like, one movie. It's going to happen over decades. And maybe one event that occurs now is not going to manifest for another 20 years, or even a couple decades. And so what we're going to see is something that seems very subtle right now or nuanced, and it's going to sort of progress. And that's really what I want to get into now. So I'll take it
Why don't
over
you
here.
share your screen there?
Just while I was reading that, I will say that while there's been one satellite collisions mentioned, there have been about a dozen collisions between debris objects that have been sort of on a lower scale. And there's lots of data suggesting that that satellites are getting hit by tiny pieces of debris all the time that's causing anomalies and things. So it is probably just a matter of time and probabilities.
Yeah, excellent. All right, so this is going to sort of be on the topic of what have we done, and what are we doing, and what is actually what's a very tangible way of sort of getting a hold of this problem, and not letting it get to that debris apocalypse sort of view. I'm not sure if you can see this here. Yeah, so what's highlighted here is the number of catalog debris from the Iridium cosmos, and that was really sort of the event that we have decided to commiserate for Space Debris Day. Now, there's another event that you can kind of see down here. This is an ASAT test. Now, this, of course, produces a huge number of debris, intentionally fragmenting your satellite with some kinetic kill vehicle. Now, we often, again, as we've been talking about, we think of collisions being the main driver to this issue, but of course, we've only seen really one collision between intact satellites. Now, of course, as Brian mentioned, we have a number of debris on debris collisions, and a lot of those go unrecorded because there's a lot of things in space. You can see here, this is about 20,000 or so objects that were tracked at this time. Now, this is the N1C. Now, the thing is that actually I went through right before earlier this morning, and I sort of downloaded all the orbital debris quarterly news. This is something released by the NASA Debris Program Office, and they're the ones that sort of do a lot of the characterization of breakup events, and sort of telling the ISS, hey, you need to maneuver here, along with the US Stratcom. Now, what happens here is I went through and I was just curious about the number of breakup events that occurs each year. And you can see in every single issue that I downloaded, going back to 2019, so this is the last 7 issues, there has been recorded debris breakup events. And now these give rise to many pieces of trackable debris. And this is something that we've known about for a long time, that we need to passivate our satellites, get rid of any on-stored energy in order for them not to explode even during their operation or at their end of life. And yet we still see about recorded 5 fragmentation events each year on average. Now, this is something that we've all touched on, and this is a sort of hyperbole. This is not exactly what's going to be the case, but if you go through and you look at all these plans, because people keep announcing new constellations and new designs and updates to their plan, it's kind of sort of hard to get a hold on what they're really trying to do. But this is something done by Analytical Graphics Incorporated, AGI, by my colleagues there, and this shows just sort of a very ominous view of the future. This is not debris. This is just satellites, right? So 57,000 satellites. It's twice the current catalog. So very scary. And what I think of is that we can launch all those satellites. That's very fine. But until we understand at a more fundamental level the effects of different forces on these objects and how the orbits change over time at that level, we're not going to be able to have this future of 57,000 planned satellites with all these different features that they're going to do. And you don't have to believe me on this. You can look at some of the big people in orbital dynamics. You take NASA or ESA or even the guys at OneWeb, and you look at what they've been doing. Now, NASA launched this IBEX Interboundary Explorer satellite in a very distant orbit, and they wanted to give an extension to its life, and they found out that that they couldn't, because actually the lunar perturbations causes this sort of chaotic instability that occurs. And so they had to reorient it. Take a look at ESA's Galileo or their GPS counterpart, and they're launching a very unstable orbital environment on account of a number of these resonances. And then when you look at the interconjunctions, sort of OneWeb or SpaceX's satellites colliding with themselves, that can also be a huge issue. And again, we still don't understand at that level, what is the carrying capacity of orbits? How many satellites can we put in a particular orbital regime in order for it to be sustainable? And this is sort of, this is what we have in the current catalog. You can see a number of objects. Most of them are about the low Earth orbit region. We also have, so I'm doing on time. We also have the geobelt that's very, very clear here. Now, this is sort of, the trackable objects. Now we're going to get a new picture of space once the, space radar fence becomes active. And of course, we have companies like Leolab, who we've talked about, who are doing a lot of this characterization of those smaller size debris that we don't track. So something smaller than your satellite. But of course, you can say that space is very big. And so what's the issue? But again, I can say that at the force level, I mean, we have, you think about Earth gravity being the dominant one, but of course the Earth is not round. It's quite different in its shape in terms of its gravitational interactions. It also has atmospheric drag. We have the gravity from other bodies. We have the radiation pressure from the sun, some different subtle forces like tidal effects and other gravity from other bodies. And we also have the fact that the satellite itself has this attitude motion, and that couples into a lot of these non-gravitational effects. So all this taken together, we don't really understand from even a short-term perspective, let alone a long-term projection 100 years from now, how do all these forces, complex forces, couple with the orbital motion and the attitude motion of the satellite in order for us to really make these, grandiose plans that we have. Now, the real thing is that, and as we talked about, is that the number of launches has become, the number of satellites launched each year is becoming quite a bit larger. This is, of course, the Starlink ones, and these are being a nice image being tracked by Leo Labs here. But so space is going to get more congested. So what have we been doing? So for a number of years now, we've been implementing what we call the 25-year disposal rule. And this is at the end of its mission lifetime in Leo. You have to lower it to, if it's a certain altitude, you lower it to another altitude lower, such the atmospheric drag will take you into the Earth's atmosphere and you will burn up. Or if it's if in 25 years the amount of fuel you have to lower, it won't do that. You need to put it into a graveyard. So we sort of created this artificial graveyard orbit, or something that we say is like kind of like a storage orbit. You can think of it as the ocean gyres of space, although these are not very stable like the ocean gyres, so they don't continuously collect objects. So this is a sort of a plan, and we can look at what happens if you continue to do that. So what we have here is that if we don't do any mitigation, we don't do that 25-year decay rule, the current projection is that the number of objects in our catalog that are above 10 centimeters is going to be about 100,000 in 100 years. And if we look at when we passivate the satellites and when we apply 90% that post-emission disposal rule, we're going to get that number carteled. We're not going to have that exponential growth. If we take out, but we're gonna have a steady state. Now, this is not accounting for the new launch rates that we have, right? That we're launching all these mega constellations. So it's been shown that we have to take out about 5 large pieces of objects per year, and there are a number of sci-fi tinged proposals to do that. And I won't have time to go into all of these, but there's a lot of research being done on what we call active debris removal. How do you take a satellite out? And one of the, there's these sort of space fishermen, tethers and the like, nets, how to remove debris. And these are all interesting ideas. It's very expensive though and complicated. And one of the ideas that I've sort of in my chaotic quest to conquer Earth's space junk problem has really been to take a step back and look at this from a dynamical point of view. And how do you really understand all those forces in a way so that you can orbit these satellites? And we've sort of looked at this from something called the Orbital Geophysical Observatory. This object was still in orbit. I should have updated this. Actually, it re-entered in September of last year. So it was in orbit for decades. And they thought it might have collided within a couple, 18 years or so of its orbit. But it turns out that it stayed up there for a long time. And if you go to the catalog and you download the observations, we have a huge number, dense observations from basically 2000 until it's and I don't have those here, but until its collision with the Earth, the reentry. We have some sparse ones here. We're missing a huge gap, and this is a big issue: is how do we track these objects and all these? It's a very complicated thing. And what we found though is that if you just look at this from a debris point of view, had you launched the satellite with 10 minutes left, you either kept it on the launch pad 10 minutes later or stalled it 10 minutes, you would have basically gotten that guy to re-enter within a couple decades. It wouldn't have been a long-lasting debris. So there is the solutions, but I guess my takeaway here, and I'll end it now, but the takeaway has been really that there's a number of solutions out there, and it takes sort of this holistic perspective to really be able to do these things, because we all want satellites. I mean, I want the Starlink to work as well. I just don't want it to ruin astronomy or to ruin our other capabilities. So there is some positivity, I guess, at the end. It's just we have to get there. So that's what this event is for. So.
Exactly, and I think that's a great segue actually into our first question, which is why we do these events, and I think this will become a tradition here at the Space Center. And Rachel, when you're doing presentations, with kids, of course we're not teaching them debris, but of course we've got lots of questions. They hear about things on the news. Where do you sort of like see from your perspective what kids in the younger generation are thinking about when it comes to space debris?
So I think that it's mostly been a positive outlook for kids learning about it through school, because no one wants to hear that there's a bunch of space debris. It's the same thing, like no one wants to hear that our Earth is dying with climate change. But I think that positive outlook is a good one. Like, and like that Aaron landed on a positive outlook, because that's how you get people to care, to not tell them that things are going to go bad, and tell them that there is something we can do for the future to mitigate these effects.
Yeah, there's a lot of there's been a lot of studies actually on when you look at some of the science communicators talking about climate change and trying to shift away from the doom and gloom, and trying to sort of put a bit more of a spin on it, and trying to put yourself as a human, or think of the future humans and the future that they will have, because they're going to have a life, they're going to have a potentially fulfilling life. It may be different, and thinking about sort of like spinning the positives on that the future is not going to be all doom and gloom. And while we want to have that positive future for them, we can do some things now to sort of like help make that a better future. Aaron, or maybe we'll end it off here. Your former student, Jeremy, how do you feel about the Indian ASAT test? Do you think this was ethical? Obviously, it's important to understand debris, AM radios, DV distributions generated from high velocity collisions, but this can also introduce thousands of long life pieces of debris if not done responsibly.
I think Jeremy here is trying to get me back for all the questions I asked him. So, yeah, it's an excellent question. I had this debate sort of before. There is no such thing as a safe ASAT test. I mean, you can't. You think about if you shoot it and the missile comes from above, right, in space. Let's say it comes from above it. Well, just from a basic physics point of view, that debris is going to spread out still to very high altitudes. You're never going to have the debris come down only. And so there's even from a very low point of low basic physics understanding, there's no altitude at which it's safe to blow up your satellite. Now, it's safer, of course, the lower you are. It is true, but the Indian ASAT test was sort of was very naive, and I think we can sort of say the US could take the high perspective and say that that's so wrong, but we've done a number of our ASAT tests as well, as the Soviet Union has done, and as China has shown too. The China one was in particular very bad because of the altitude. The one that India did was a little bit lower, so it was a better ASAT test, but I won't advocate for any of those. I think that it's a very bad thing to create debris, because some of these things can last for hundreds of years. So the China one, those pieces of debris naturally will not re-enter for hundreds of years, even some of them thousands.
So if there's any kids out there that are watching this on YouTube, one main takeaway about space debris: we can't just blow it up. I know that's maybe that's what you're thinking, that maybe we can just shoot it down, like maybe just create like a video game, get some of like our best kids that are really good at
Yeah.
asteroids and put them in there. But it's not going to happen. Well, Aaron, Brian, Rachel, thank you so much for coming together for another Space Debris Day. Aaron, where can people learn more about you and your space debris advocacy?
Sure. So yeah, I recently started a new Instagram. Well, actually, my first Instagram page is called The Recovering Professor. So I give a little insight into the life of a space junk scientist, or a space garbage man, if you will. So you can find me there. It's at The Recovering Professor. I'm also very active on LinkedIn. And that's pretty much it. I have a website on my university page. I don't know what that is yet. Yes, I'm a faculty member at the College of School of Engineering, Jacobs School of Engineering at the University of California, and you can of course find my email online there, and I'm happy to answer questions, widely from public to something very scientific. So always looking for new inspiration. Thank you.
Awesome. Brian, where can people learn more about you and the Secure World Foundation?
Yeah, absolutely. They can visit our website, swfound.org. They have a lot of materials there. I'm also pretty active in both LinkedIn and Twitter, talking about a wide range of space policy topics. So those are probably the best places to find us.
Awesome. Thank you so much. And Rachel, we're going to be back here tomorrow at 2 p.m. This time tomorrow. We're going to get into the 2 big Mars missions and preview next week's big Mars mission. So we're actually selling tickets for our Cosmic Night on the 18th. We're going to be joined by Dr. Tanya Harrison, getting into how we figure out where to land all these Mars missions. And if you want to join us, we're also doing an online event on Sunday for Valentine's. Rachel and I are going to be doing some stellar shout outs. If you have someone that you've missed in your life, lots of us are locked up in our homes. So if you want to send a stellar shout out to someone, send us a message. Rachel and I will find a star. We'll chat about it. We're going to have some fun on Sunday for Valentine's Day. So you can always check out all of our events on spacecenter.ca. All right. From the Space Center, that's all. Take care.